Now I'm going to do simultaneous equations. Simultaneous equations, guys, are different than linear equations. As we mentioned in the previous recording, the linear equations, guys, we have only one unknown variable. But in simultaneous equations, just now you're going to see we have two unknown variables. Okay, that's where then we have to obviously uh, solve the equation and knowing that we have two different unique answers. All right, so we say simultaneous equation, guys. In this chapter, when we're done with this, we will be able to solve simultaneous linear equations by substitution. We will be able to solve simultaneous linear equations by elimination method. And then we solve simultaneous linear equations using the straight line graphs. Now, we're not really going to speak about the graph because that's something you will do later on, maybe in grade 10. Okay, so we say if an equation has two unknowns, such as 2y plus x equals to 20. Guys, as you remember in linear equations, if it's 2y, then it's plus a number equals to 20 because it's only one unknown variable. But now here, as you can see, 2y and x, they are two different variables, y and x. All right, so that's why we cannot solve this the way we solve linear equation. Okay, so we say it cannot have unique solutions. Two unknowns require two equations which are solved at the same time, simultaneously. But even then, two equations involving two unknowns don't always give unique solutions. Now we're going to look at some of the examples and see how we do it. Okay, the first one, guys, is elimination method. Okay, how are we going to use this method? The elimination method, guys, is to solve the simultaneous equations, make the coefficients of one of the variables the same value in both equations. Then either add the equations or subtract one equation from the other. Okay, whichever one is appropriate for us, then we can do that to form a new equation that only contains one variable. The example will be this. Say, for example, we have this, right? 4x minus 2y equals to 4, 5x plus 3y equals to 16. So I'm going to make either, as you can see now, I have two different unknowns, x and y. I'm going to either make x in this equation and x in this equation equal, and then I'm going to make them in opposite sides. So if this is negative, this has to be positive. They're going to be equal and in different signs. One is going to be positive, the other one is going to be negative. Or I'm going to work with y's, x and y, two different unknowns. It doesn't matter whichever one we can work with, right? But the thing is, they must be equal and in different signs. So that and then we add them together. So when we add them together, because they are equal and in different signs, that's why they will eliminate each other. It's basically like we're adding -2 and 2 together. They are equal, right? 2 and 2, -2 and +2. When we add them together, they will cancel each other, right? So by doing that, one of these variables here, one of these unknowns will eliminate each other. Then we'll be left with one. We'll be left with one variable, right? So then it's going to be like a normal linear equation. Then it will be easy for us to solve. Okay, right. Let's look at this example here. As you can see here, guys, -2y, and we're going to do y, -2y plus 3y. So I'm going to use number 3, right? And for this equation, and number 2 for this equation. I'm going to make the y's equal and in opposite sides, different side, right? One is going to be positive, the other one is going to be negative. But guys, bear in mind, when we're using the number for the equation to make one of the variables equal, we're going to multiply that number with everything inside that equation. So, for example, in this one, I'm using 3, right? So I'm going to start from here. 3 times 4 will be 12. 3 times -2y will be -6y. 3 times 4x will be 12x, right? I'm using 2 for this. 2 times 16 is 32. 2 times 3y will be 6y. 2 times 5x will be 10x. Now, as you can see, guys, negative 6y and positive 6y. Now I'm going to add these equations together now, right? The reason I did this was, like I said, I'm going to make one of these unknowns here equal and in the opposite signs. As you can see, negative 6y, positive 6y. So when I add them together, they will cancel each other. So there will be no y anymore. I will be only left with x. Okay, let's do that. 12x plus 10x is 22x. Negative 6y plus positive 6y is 0. I'm not going to write it. 12 plus 32 is 44. Okay, now as you can see, it's a linear equation because I canceled the y's, I got rid of them. Now there's only one unknown variable, which is x. 22x equals to 44. Divide both sides by 22. X will be 2. Okay, so now once I find x, then it will be easy for me to find the other unknown, y, because I'm going to put this 2 in one of the equations, that it will give me the other unknown. Okay, so let's look at this. 5x plus 3y equals to 16, right? So using this x in this. Now, as you can see here, 5 times 2, why? Because I know what the value of x is. I'm not gonna say 5x again, because I know what it is. It's 2. So 5x means 5 times 2 plus 3y equals to 16. 5 times 2 is 10 plus 3y equals to 16, right? Then I'm going to leave this 3y alone here, send 10 to the other side of the equation. 3y will be equals to 16 minus 10 will be 6. So 3y is 6. Divide both sides by 3. Y will be equals to 2. So x is 2, y is 2. If you guys remember when we did in class, guys, the variables that we are eliminating, we write it right in the front. So then it will be easier when you look at it, you don't really get confused. It doesn't matter, there's no difference. You can leave it here or you can put it there in the front. So if you put it in the front, so this is basically going to be negative 2y plus 4x equals to 4. This is going to be 3y plus 5x equals to 16. Okay, then when you multiply, use these numbers, multiply them, it's going to be the same thing. So there's no difference where it is. It can be in the front, in the middle, or anywhere. Okay. Now let's look at the other method, which is substitution method. Okay, we see substitution method, guys, can be applied in 4 steps. We solve one of the equations for either x or y. We substitute the solution from step 1 into the other equation. We solve the new equation. Then we solve for the second variable. Right. Then we say solve one of the equations for either x or y. Let's look at these examples here. Right, these are examples of simultaneous equations in substitution method. If we have to this, guys, y equals to x minus 3, 2x plus 4y equals to 42. Okay. Right, this means, guys, substituting one equation into other. So I'm going to find either x in terms of y or y in terms of x. But as you can see here, guys, I know what y is in terms of x. Y is x minus 3. So this means in this equation, when I see y, I'm not going to write y. I'm going to say x minus 3. Why? Because if I say y, that doesn't help me. X and y, I have two different variables, so I cannot solve this equation. But if I write y in terms of x, then I will have only one unknown variable, as you can see here. If I say y is x minus 3, so I'm going to say 2x plus 4x minus 12. So instead of y, I'm going to say x minus 3. Why I'm doing that is because I want to have only one unknown variable, which is going to be y. In this case, it's y and x. I can't solve. It doesn't help me, right? That's why I'm going to find the one unknown in terms of the other one. Okay, so what we say is replace with x minus 3 in the second equation. Okay, so if I do that, 2x plus 4y equals to 42. Now I'm going to write what y is in terms of x. So as you can see here, y is x minus 3. So 2x plus 4y means 4 times x minus 3 equals to 42. Then 2x plus 4x minus 12 equals to 42. 6x minus 12 equals to 42. 6x will be, take this negative 12 to the outside of equation, equals to 54. Divide both sides by 6, x will be 9. Okay, so basically, guys, what we did is we found what y is in terms of x, because I don't want to have two unknowns in my equation because I can't solve it like that. That's why I'm going to find one of the unknowns in terms of the other one. In this case, I found y in terms of x. So in my equation, I have all x. As you can see, everything is x, no y. Then it's, once you do that, you have only one unknown variable, which is x. Then it's a linear equation, so you can solve it. So if we follow the steps, guys, then we found x is 9. Like I said, guys, once we find one of the variables, then it's easy to find the other one. So I'm going to take, since I know what the value of 9 now, I'm going to take it, put it in one of the equations, and find what y is. So as you can see, I said y equals to 9, x minus 3. I know what x is. X is 9. So if I put it here, y equals to 9 minus 3, then y will be equals to 6. Okay, so guys, so basically this is what it is about the simultaneous equation. We have two methods. One is elimination method, the other one is substitution method. Now I'm going to continue with more examples.